Alright, so I'm going to discuss a little about the sinusoidal function, which is y is equal to a sine b times x minus c plus d. Okay, so in this, when I talk about the a value, correct, this connects with the transformation. So all of these that are there are somewhere connected to the four transformations. Now, what are the four transformations we're talking of? This will be translation. Okay, after translation, we'll come across a stretch. Okay, which is also called as enlargement, dilation, same thing. Okay, and then when we talk about this thing, the reflection. Okay, and the last one that we'll be talking of would be this one, rotation. Okay, but please note, rotation is not a part of the DP syllabus, so we won't discuss this. Okay, we just discuss the first three. All right, so in translation, all of them, that is we could have either horizontal one or a vertical one. Okay, when we talk about the a value, correct, a is something that connects with the stretch. Okay, this stretch is the vertical stretch. Okay, so in the vertical stretch, this a value can be positive or negative. Now, some aspect of this was also seen in a quadratic function. That is, when the a value is positive, right, we get a function which is open upwards, and when a is negative, we'll get a function which is open downwards. Correct, and this a essentially deals with the amplitude of the sinusoidal function. So if I'm discussing about the sine function, right, this is how generally a sine function looks like. This is when the a value is positive. Okay, but if the a value is negative, right, it will be a reflection along the x-axis, which will go like this. A is negative. Okay, so we covered about the vertical reflection and the vertical stretch. So a is essentially giving us this length. Okay, I'll quickly highlight it. We are discussing about this length. This is what is a. That means its distance from the principal axis. Now, what's a principal axis? It's the axis along which the sine function will oscillate. Okay, so it goes up and down along that line. That is what is called as a principal axis. Okay, so that was for the a bit. Now, after that, what we'll do is that we'll discuss the next variable, which is the b part. Okay, so when we talk about the b, right, b is connected with a horizontal stretch. Okay, now when we talk about the horizontal stretch, it is the scale factor. Okay, so this we studied in the transformations. In the transformation, the scale factor is always 1 upon, or it's a reciprocal of whatever is given in the function. Okay, so the scale factor is 1 upon b, but when we are talking about a trigonometric function, okay, there's a way to connect it with the period of the function. Okay, so please note the b that is there is what is connected with the period. Okay, how does it connect with the period? B is equal to 2 pi over period if you're discussing it in radians, or else if the question says it's in degrees, so it is 360 over period. Okay, next, please. Yeah, the next component that we come across is a c value. Okay, now c is essentially connected with the translation. Okay, and which translation? This would be the horizontal translation. Okay, so when we talk about the horizontal translation, as it is already given that it is minus, so as per the c value, okay, if the c value is positive, then it will move to the right, and if c value is negative, it will move to the left. All right, the best way to find the c value is right towards the end. Okay, so whenever you're solving or you're finding the values of a b c d, like from the graph that is given, right, so you'll always find the c value the last. Okay, how do you do it? You substitute the value of x, y, and all the other constants. Okay, substitute all the other constants and then find the c value. Or else the other way to do it would be, let's say the function that is there, ideally the sine function should be looking like this, right? But let's say if it is moved pi by 2 units to the left, then the function would go somewhat like this. Okay, kind of made a mistake, but it's okay. Yeah, so it's moved pi by 2 units to the left, so this would be given as y will be equal to sine of x plus pi by 2. Okay, plus because if it is minus of minus pi by 2, right, I told you if it's to the left, yeah, I'll just elaborate it. Sine of x minus of minus pi by 2, right? To the left means it is negative pi by 2, but then in the part when I had mentioned already, this part is minus c, so that's why negative times negative makes it positive, and that's why this is our answer. Okay, next bit. Now when I talk about the d value is connected, or it is connected with the vertical translation. Okay, vertical translation. So if the d value is positive, the function would go up. D value is negative, it should go down. Okay, and by how many over units, you can get it from the graph. Okay, a summary of the whole thing is mentioned over here. You can have a look. And amplitude is absolute value of a here, correct? Because the amplitude cannot be negative. So if you notice over here, I'd mentioned that a value can be positive or negative, but if they're asking you in the question that it is the amplitude, find the amplitude. Okay, so that you will be finding absolute value of a. I hope this makes sense. All right, let's go. So yeah, everything is mentioned over here. Please have a look. I'll wait for a few seconds. One very important thing before I forget, this part that is there. Now the function that is there, a sinusoidal function can be given as y is equal to a sine b x minus c plus d. Okay, or else it could also be given as y is equal to, hold up, yeah, okay, yeah, y is equal to a sine bx minus c plus d. Okay, so what is the difference between these two? Obviously you could notice that the brackets are open, the expanded, and in the other one there are product of the brackets, right? So in the first case, what is happening is there is a vertical stretch, sorry, horizontal stretch happening before the horizontal translation. Okay, so in first case it will be horizontal stretch, then horizontal translation. Okay, but if you check the second one, in the second one what is happening is first there's a horizontal translation, and then there is a horizontal stretch. Okay, it depends, so it completely uh, depends on the type of question that they're asking. Okay, so in the question if they've already given the function, please be very mindful of this. Okay, next, so I had already put up a few functions over here. The left one that is there is the sine function, y is equal to sine x, just, and is the angle measurement is in degree, in radians. So if you notice this part that is there, this, okay, so where it is starting, from the starting to where the same function repeats itself, so this length is what is called as a period. Okay, next part is the amplitude. So amplitude over here will be 1. Okay, next part, if I want to find the b value over here, b value will be what, 2 pi over the period, which is 2 pi. And additional thing for the period, this could be calculated from either a crest to crest or trough to trough. Okay, like from this point, the highest point to the highest point, or it could be also calculated from the lowest point to the lowest point. In all the aspects, the period will still remain the same, which is 2 pi. Now in this case, if I do b is equal to 2 pi over 2 pi, because this 2 pi is what is the period. Yes, so the b value will come to 1. Okay, if the period changes, then the b value will also be different. Alright, and in this case the d value is 0. Why? Because there's no vertical shift. This is at the x-axis itself. The principal axis is at the x-axis. Alright, now this one that is there is what is a cosine function. Y is equal to cos x In the cost function, please note it always starts from the highest value. So it starts from 1, and here at 2 pi it is completing one cycle, so that becomes the period. Okay, the period, amplitude, everything remains the same as what we had discussed for the sinusoidal function. Okay, next bit. Okay, let's give it a minute to hold to load. Yeah. Okay, so this was one of the questions that was asked to me quite recently. So in this, I just thought, okay, why not we try doing this one first? Okay, so first things, the moment I see this, I could understand that it's a sine function. Why is it a sine function? Because the starting point is 0. Okay, so I know that it somewhere belongs to the sine function. Okay, now if you see, I've left some space so that I could fill up the coefficients or ABCD, the unknown values. Okay, now what's the amplitude in this case? If I check the amplitude over here, right, from the principal axis to the maximum points, so that is 3, so that gives us that the A value should be 3. Okay, so A value should be 3, right? Then if I check the B value, now for the B value, what do we do is we find the period. What's the period? That means from 0 to this point somewhere it is ending. Yes. Okay, so that is not giving us an exact value, correct? So what is the other way to work around this? So if you notice, this is 0, and at 2 pi again the function is being repeated beyond that as well, correct? So from 0 to 2 pi, how many cycles are being completed? So if we check, this is 1, 2 and 3, so there are 3 cycles being completed, correct? So the period that is there, the period will be what? In 2 pi there are 3 cycles completed, so the period will be 2 pi over 3. Now if I want to find the b value, correct, the b value will be given as 2 pi over the period. So I'll get the b value to be 2 pi over 2 pi divided by 3, so the b comes to 3. Okay, there is no shift that is happening, because if you notice, this point that is at, this is right at the starting point, right, and there is no horizontal shift that is happening in the function. So, and also there is no vertical shift, okay, because this is at 3 and this is at minus 3. Alright, so the function will come to y is equal to 3 sine 3x. Okay, another way, if we have to calculate the d value or the amplitude, right, so it could also be done by using the maximum and the minimum values. Okay, so if I want to find the a value, so if you notice, this a value that is there, correct, from the maximum and the minimum, if you want to find that, okay, so a will be what, it is covering twice the amplitude, so 2a will be equal to y minimum plus y maximum minus y minimum, y max minus y minimum. So that gives us that a value could easily be found out as y maximum minus y minimum. This you can apply for any complicated questions that would be asked. Okay, next thing would be to find the d value. Okay, now in this case we know the d value that is there is at the origin, in is the x-axis itself, correct? But if there's a question, so the d value will be what? It will be right between the maximum and the minimum, correct? So that could be also obtained by the mid value. So what I'll do is that I'll do y max plus y min, the minimum value, whole upon 2. That will and this is y is equal to that number. That becomes your principal axis, which is also your d value. I hope that makes sense. Okay, next one. So when I'm discussing with this about this question, so what is happening over here? When is one cycle? Again, it first of all belongs to sine function, correct? A sine b x minus c plus t. Okay, so a. Next, what's the amplitude? Amplitude would be 2 because it's oscillating about it. We could easily observe that from the graph. Okay, then if you check what's the period in this, period will be 2, so that means the b value will be 2 pi over 2, so the b comes to pi. Okay, next thing, what about the c value? Is there any change? No, it is starting from the origin, so we can assume the c value is 0 and the d value is also 0. So this function will be y is equal to 2 sine pi x. Hope that makes sense. Okay. Similarly, for the next one, okay, there was one more question. Please give it a few seconds till the time it loads. Never mind. By the time that loads, what we'll do is that there's nothing. Okay, never mind. Let's end the session here. I hope it was quite this thing, informative. See you guys later. Bye bye.